All right, so this is 4-4, and it's on scatter plots. Have you guys heard of scatter plots before? All right, you guys did a little bit of the work on, I guess, Thursday, right? There's like 2 IXLs or something like that. There's like 2. It was super easy from what I saw, correct? Okay. So we're going to get into that maybe a little bit later. But scatter plots is basically just a collection of points that we all plot on a coordinate plane. And this is very, very useful. Okay, it allows me to kind of predict trends, okay, or make an educated guess, Harshan, okay? Now, let's look at this. It says, work with a partner. We're all going to be partners here, okay? So it says the survey was taken of 179 married couples. Each person was asked his or her age. The scatter plot shows the results. So first off, what can you tell me about the scatter plot? So just look at it. So look at the scatter plot. Tell me, what can you tell me? Drew? Okay, most of the dots are in the 30s and 40s. What does that tell me? And just in case you guys didn't know, this is the section I really like. This is like one of my favorite stuff. Okay. So what does that tell me? What's the or what are we surveying here? Husband and wife's age, married couples, right? Okay. So what do we know? Okay, it's a positive trend. All right, Drew said most of the dots are in like the 30s to 40s, right? So it says most married couples that they surveyed were in that age group, right? Now, we can kind of get a little dark here, okay? So why are there less married couples, say, after 60? What's that? All right. Unfortunately, the older you get, I think you guys can see where I'm going with this, right? People don't live too long, okay? So, of course, that happens, all right? So that is one thing we can like kind of like pull from this, is that most people are like in that 30 to like 50 range, right? After that, life happens. We'll leave it at that. Okay. What else can we gather from this information? What's missing, like down here? Yeah, most people aren't getting married in their 20s, right? Think about it. There are some people that that get married in their 20s, right? But most people are getting married in their like 30s, agreed? Like early 30s. And that kind of like, is captured here in this data. And then Sophie said it's positive, going up, right? Now, here's another fun little thing about this, right? Judging by this data, okay, do you know what I can kind of like interpret? You marry people around your old age or your own age, right? So notice all of these points are really close together, right? These ones that are off the line are ones that are like, all right, one person's a little older than the other, okay? Notice they're not too far off, are they? So like this one point right here, if I look at that, that seems a little, off because that person's like 54, the husband's, 54, and the wife is 63. Okay, which is, it's kind of like what I think of is Celine Dion and her husband, Renee. Celine Dion. She's best. All right. So Celine Dion married her husband, and Mrs. Potts, how old was Renee? He was like,
He was 20 years older. Wasn't
yeah, it's like 20 some years older. So not everybody's like that. All right, so up here it says draw a line that approximates the data. Okay, now when we're doing this, okay, what we want to do is we want to draw a line that goes through most of the points. Okay, so what do I not want to do? I don't want to draw a line like this. That doesn't really capture my data. I don't really want to draw a line like this because that doesn't capture my data. All right. So what I do want to do is I want to draw a line that goes straight through my data. Now everybody draw a line that goes straight through their data. Okay. I'm going to draw mine a little better. All right, now they ask me to write the equation of a line. So I need two things to write the equation of a line, Harshan. What are they? The slope and think about our last test. Starts with a P, ends in point. Starts with a P, ends in point. Point. All right, so up here, we're going to approximate our slope. So how am I going to do that? I'm going to try and pick a point that is on my line where my line goes through the corner of a box. I'm going to say right about there. That's the point 30, 30. And then I'm going to choose this point right up there, which is 75, 75. So to calculate my slope, I'm going to do 75 minus 30 over 75 minus 30. Now yours might be a little different. Do it for your line, okay? So try and find 2 points such that your line goes through the corner of the box, or estimate it. Like notice I'm not perfectly on that point and I'm not perfectly on that point, but I'm using those to estimate it. And I'm finding that my slope is 45 over 45, which is 1. And now I need a point. So let's use this point of 30, 30. Now recall from your last test, it was y minus y1 equals m times the quantity of x minus x1. That was my point slope form. So if my y1 is 30, I have y minus 30 equals 1 times x minus 30. And I'm done. And the method I used was I calculated the slope and used the point slope formula. And while you guys are doing that, okay, and this is no joke, when I interviewed for my job here at Pencrest High School, okay, they asked me to teach this lesson, Hope. And do you know what I did? I taught this lesson. Like, it was awesome. Do you know what I did? I took gas prices from like the 1970s, which in the 1970s, they were like less than $1 for a gallon of gas. And I got hired here in 2007. So what I did is I took all of those points and I had kids plot them and we calculated the line of best fit. And then we used that line of best fit to actually make a prediction about what the gas prices would be based upon the gas prices in like the 1970s in 2008. And guess what we found? We were within like 3 cents of what they should have been. Crazy, right?
Wait, can I use your math?
Yes.
Mr. Herman, have you seen the scatter plots on Naviance for colleges?
No.
They're very helpful. You guys get older, you'll go into Naviance. Each college has a scatter point, based on your SAT scores and your GPA.
Oh,
And they
yeah.
crisscross and they'll show you acceptance, from pen press, decline. So it's pretty cool.
So it's kind of like what they were talking about, a sliding scale. Like if your GPA is super high, your SAT scores can be a little lower.
Well, wherever they intersect, and now that particular college will have a point where their acceptance is, and you can kind of see
Huh.
where kids who have been accepted, what their numbers are, and kids from Penn Press that haven't, and get an idea.
Check that out. I did not know that. Cool. Thank you. All right. Let's look at this one. What conclusions can you make from the equation you wrote? Explain your reasoning. The inclusions. All right. My conclusion was we marry people that are relatively close to our own age. Okay. That was mine. How did I make that? By my slope. My slope was 1. My age and my wife's age were both within a year. Okay, I'm 36, she's 35. Okay, she'll be turning 36 in the summer. But, okay, you marry people around your own age. You know, we talked about that. It's about true, right? Think about your parents, okay? Think about people you know, okay? And they're roughly about the same age, okay? All right. Next question. So let's turn the page. The scatter plot shows the median ages of American women at their first marriage, selected to years from 1960 through 2010. Okay, I don't know why this is all about marriage, but it is what it is. All right, so Jordan, it says draw a line that approximates the data. Do you think you can do that? All right, let's all do it. Everybody draw a line that approximates the data. See if I can get a better line than that. Yeah, I don't like that one. Sometimes it might take you a few tries. That was pretty good. All right. So why did I pick this line, Harshan? Why wasn't I happy with my other lines? Okay. Well, here's the key. Harshan, do you see how I go through this point, and this point? See how I go through like 3 points? Okay. 1, that's pretty good because that means I'm capturing 3 of my 12 pieces of data. Here's the other thing. I don't have to go through all the points. I don't even have to go through any of the points. But what I do want is I want the same number of points like above my line as below my line. I want that to be to the best of my ability. Now notice here, I have 1, 2, 3 points below, and I have 1, 2, 3, 4 points above. Do you see that? Do you see how all of these points above are pretty close to all those points below? Like they kind of cancel each other out, meaning they're the same distance alike. Do you see that? That's a sign of a good best fit. Okay, now let's talk about this. Ages of American women at first marriage. In 1960s, what was going on in the 1960s? AJ, do you know? Okay, we have like a depression happening. Anybody else at home? Let's go with Nate. What was going on? Okay. What about, who else do we have? Neve. Neve, what was going on in like the 1960s? Are they muted? All right. Or not.
Was it World War II?
Okay, thank you, Emma. We were like coming out of like a war, right? So why would women get married earlier? Well, because of benefits and things like that. So they were getting married earlier because their husbands were like going to war, right? So they would get married and then receive the benefits.
This is Vietnam.
Vietnam. But weren't they just coming out of one war too? I think,
1960?
but when was World War II?
Probably today.
In the 40s, right? And when did it end? Okay,
Vietnam and women's lib, civil rights.
so that's why I teach math, but that's why I got Drew here. Mrs. Foss here, keep me straight now. So we were coming out of a war and we were getting ready to go into a war. And then we had a lot of other stuff going on as well. But women were getting married earlier so that if something happened, they would be kind of like taken care of. All right, so that's why they were getting married earlier. Okay. Any other reasons why they might be getting married earlier that anybody could think of? So he's like, I did not see this math lesson going this way today. Got to keep you on your toes. All right, so it says write an equation of a line. Let x represent the number of years since 1960. Okay, so let's take 2 points. I'm going to take that point. That is 1960. Okay, and that is the point 20. And then I'm going to take this point, and that is the point 2005. And I'm going to say that is 25. Now, notice it says number of years since 1960. So this is really like the point 0 and 20. And this is really like the point 45 and 25. So to find the slope, I'm going to go ahead and do 25 minus 20. You guys doing this as well? Over 45 minus 0. It gives me 5 over 45, which is 1/9. And now I'm going to use the point 0, 20. So it gives me y minus 20 equals 1/9 times x minus 0. What conclusions could you make from the equation you wrote? That women tend to get married younger. All right, it's not going up. So as the years progressed, women got married older, but not nearly at a, I guess, a crazy rate. So in 45 years, it only went from 20 to about 25. So use your equation to predict the median age of American women at their first marriage in the year 2020. So 2020 would be 60. All right. So I'm going to be putting in that 60 for x. So the equation, it was y minus 20 equaled 1/9 times x minus 0. So 2020 would be x equals 60. So I'm going to plug that in. So I got y minus 20 equals 1/9 times 60 minus 0. It could be y minus 20 equals 1/9 times 60. 1/9 of 60 is roughly, let's see, 6.6. So y minus 20 equals 6.6. So y equals about 26.6 years, meaning women get married around 27. I think that sounds about right. Do you guys have like friends, family that get married, right? They get married like late 20s. AJ, do you have anybody? Cousins?
Yeah.
Late 20s, right? See, look at that. Crazy. So how can we use scatter plots and lines of best fit to make a conclusion about our data? Well, we can use it to predict the future, and we can use it to interpret our data. The closer the data is together, like the tighter that line is, okay, the better the data goes together. I can put any two things and put them on a graph together, like hair length and grades in class. Do you think they have anything to do with each other? No, but I can plot them and they could be all over, and it doesn't really mean anything because they don't plot. We want it to be as close together as possible. All right. Do I have time to get this one done? All right. We're going to pause here. I know it's a little early, but we're going to pause here because I don't think I have time to get this one done on our calculator. All right.